Hi, uh, good morning to all. I'm Hemalika from the Department of EEE and the College of Technology. Today, let us see about the control system. First of all, what does memory control system means? In a system, the output quantity is controlled by varying the input quantity. It is simply called as a control systems, and it is divided into open loop and closed loop control systems. And we have to find the transfer function, that is the Laplace transform of output to the Laplace transform of input. And let us see about the block diagram techniques. And this is the representation of block diagram. Um, Here we have to find the transfer function which is in the output to the input, that is a y of s is your output and r of s is your input. Here they mention open loop and closed loops. Here there are some of the parts is, that is first one is a block which is nothing but a represented systems with the transfer functions, and it is segregated with some of the blocks. And next one is a signal, that is your signal is going from input to the output blocks, that's indicated by your arrow marks. It could be a voltage, force, etc., velocity and all. And next one is a summing junctions, that is all the points are connected together, which point is called as a summing junctions, that is a algebraically summed fractions. And next one is a standard block diagram forms. It is in a three basic forms, that is cascade connection, parallel connection and feedback connection. And this is your basic block diagrams, that is with nothing but a g of s is a gain of the systems, and y of s is your output, and input is e of s. How to find your output means, that is your input into your blocks, that is your gain of the systems. And next, let us see about your cascade form. That is, it is connected seriously, which is called as a cascade connection. That is, all the gains blocks are simply connected together in a some point. That is, it is connected through one lines. That is called as a cascade form. We have to find output means, here we are considered three gains, that is G1, G2 and G3, which is connected in cascade connection, simply connections. And how we find the output means, that is output is equal to input U of s into G1 of s, G2 of s and G3 of s. This is your final output. Here the output quantity is controlled by varying your input quantity. And next one is a parallel form, that is in one summing point, three blocks are connected to the parallel. That is, we have to simply add. In cascade connection, we have to multiply, but in your parallel blocks, we have to add all the 3 points, which is your output is nothing but y of s is equal to u of s into g1 of s plus g2 of s plus g3 of s. And next one is a feedback form, that is already I told, that is control system is divided into or classified into open loop system and closed loop system. Open loop system is nothing but, here there is a one input, your gain, and next one is a, that is your system, and to the output there is no feedback to your input. And but closed loop control systems, the output quantity is controlled by varying your input quantity in the form of, sorry, in the terms of feedbacks. So here R of s is your input and Y of s is your output, and H of s is equal to feedback and G of s is gain. X of s is your values, that is signal values, and E of s is equal to your error signal, that is summation points. Here feedback is negative feedback and here positive feedbacks. From this, you have to find this is a negative feedback control systems. Here we have to find the transfer function, that is y of s divided by r of s, that is called as a transfer function t of s. How to find means g of s divided by 1 plus g of s into h of s. This is your negative feedback control system. And next one is a positive control systems. That is your transfer function is reversely, that is g of s divided by 1 minus g of s into h of s. And next one is this is your simply uh, closed loop systems. That is here. This is your H2 of S equal to some values, and this is one your gain, and this is your feedback. All is connected together, and we first have to simplify these blocks. That is, these two are in cascade connection. That is, d of s into g of s is well in a multiplication, and again this is your feedback loops. That is, this is your negative feedback. So your values is d of s g of s divided by 1 plus d of s g of s into h1 of s. This is the overall functions. And next one, and finally this is your gain, that is your final values is h1 of s into this is again this one, and this one is again cascaded, so have to multiply, simply multiply, that is t of s is equal to y of s divided by r of s equal to h2 of s. This is h1 of 2 of s into d of s g of s divided by 1 plus d of s h of s into h2 of s. Next one is a unity feedback system. That is, there is no values in this your feedback. That is, your feedback values is 1. That is called as a unity feedback. How to find the transfer function means, that is t of s is equal to d of s g of s divided by 1 plus d of s into g of s f, that is h of s values is 1. So it is called as a unity feedback systems. And this is your block diagram algebras. That is, there are three standard forms, that is cascade connections, parallel connections. And next one is some of the summing point, that is we have to change the summing point value, that is two block diagrams are equivalent. Here u1 of s, u2 of s and g of s. How to simplify this one means, that is here u of s and previously g of s into g of s summation means, that is here un of s plus u2 of s into g of s equal to u1 of s g of s plus u2 of s g of s. This is same, left and right are same. And this is the moving blocks forward point to a summing point, that is g of s is in left side, we have to above, that is agate of the block means, which block is agate means, that is you have to put 1 divided by g of s values. And these are all the pick points, that is moving the summing point after the block and moving the summing point before the blocks. These are the after, and this is yeah before the blocks. And this is your example problems, that is rearrange the following unity feedback systems. First one, move the feedback block, that is h of s forward path to the summing point, and add an inverse block, that is we have to move here. So we have to, before means we have to add the r of s compensation for the move, that is 1 by h of s values. And this is your example 2, block diagram simplifications. First, we have to, this is your feedback form. So what is the values means? This is your a positive feedback. So your values is in negative. This values is g1 of s divided by 1 minus g1 of s into h2 of s. And next one, moving this point to left side. That is again, this is your cascade connections. You have to multiply. Again, it is a forward path kind loop. That is your negative feedback loop. And this values is G1, G2 divided by 1 minus G1, H1 plus G1, G2, H2. And next one, this is your parallel path. So G4, G2 plus G3. G4 divided by G2 plus G3. Have to simplify. G2, G3 plus G4 whole divided by G2. And finally, yeah, how to find the transfer function means y of s divided by r of s is equal to g1, g2, g3 plus g4. That is, we have to simplify g1, g2, g3 and plus g1, g4 whole divided by 1 minus g1, h1 plus g1, g2, h2. Okay, thank you.